Hello everyone. Today's problem is to count the subarrays with fixed bounds. So let's understand the problem. So it says that you are given an array of integers nums and you have two more integers. These denote the bounds. So min and max and a fixed bound subarray. So first of all, if you have an array, any contiguous part of it containing one or more elements is a subarray of this entire array. So it's important. You cannot skip any elements. So this is a subarray. Now next we have fixed bound subarray. So it says that all the elements in this array should be less than equal to max k and greater than equal to min k. And in fact, the minimum of these should be exactly equal to min k. So min should be equal to, so there is no greater than less than. So min in this part of the subarray should be min k and max, maybe max is somewhere here, is exactly equal to max k. What does that mean? All the other elements will be between min k and max k. If any element is less than min k, then it violates that the minimum is min k because that element is minimum. Similarly, if any element is more than max k in this subarray, then it violates that maximum is equal to max k because that element will be maximum. So I hope now the definition of fixed bound subarray is clear. So let's take an example. So this is our example. So this is the array and then minimum is 1, maximum is 5. So if you see this subarray, clearly min is 1 but max is not 1. Then you check this subarray, here max is 3, min is 1, still max is not 5. Now if you see this subarray, first three elements, here min is 1 which is equal to the given bound and max is 5 and all the other elements are in this range. So this is one of the uh, max bound subarray, or what's it called, fixed bound subarrays. So this is one. So you have to return the how many fixed bound subarrays are possible. So we got one, 1, 3, 5. Next, 1, 3, 5, 2. This is also valid because if you see 1, 3, 5, 2, min is 1, max is 5, and all the elements are between that, of course. So 1, 3, 5, 2. We got 2. Are there any other possible? No, because if you extend it further, 7. 7 is larger than max k, and so it breaks there. So whenever you encounter any out of bound, whether it's more than max or less than min, it breaks there because it cannot be included in any fixed bound subarray. Subarray is contiguous. So as soon as the subarray cannot start from left side of this and go beyond it because it will include this and this is out of bound. So the entire subarray will be invalid. So here, so you cannot include 7. And if you go beyond that, beyond 7 also, no subarray exists which satisfies this condition. Of course, max is 5, but if you see min is not 1. So only two possibilities are there. So for this input, you will return 2. Now let's see how we can solve it in general. So let's say we have an array and let's say from here to here, the elements are valid within min k and max k. Then there is one out of bound element. Then a few valid elements, then again, let's say out of bound elements, and then some more elements. So clearly we saw that we have to find all the fixed bound subarrays in this part plus this part and this part, and then add them together and return the result. Because these are splitting the array, so no subarray can include these. So how we can solve it? So we start from here. let's say first index. So let's start from first index. So this is the array, and let's have a few indices. Let's say the index of min is here -1, initialized to -1. So here index is starting from 0 1, and there is some idx2 also equal to -1, and then this is the current invalid index. So let's say this will be, so with this initialization it will be true for a generic case. Let's say we found the solution in this part, and we are iterating through this list, and when we encounter it here, we come here, we see that it's out of bounds. So let's uh, reset these indices. So now the invalid index comes here, which is one before the first valid index, same as here before the start of the array. So this case will work for all the cases. Now what we are doing, so let's say let's all these three parts, or in general k parts, will be identical. We will focus on just one of these uh, range between two out of bounds numbers. So let's say we have an array from here to here, and all the elements are in this range only, min k and max k. So currently, just before that, there was some invalid index, and in the beginning also this -1 is just before invalid index. So here we have invalid index, and somewhere here we would have some indices, idx1 and idx2. Where they are doesn't matter because they are less than first valid index. So yeah, so now when you see what is this element, this is within range. Is it equal to min k? Let's say not, neither equal to max k. So what we are doing is that we are trying to find like how many fixed bound subarrays end at current index. So let's say we are at index I here, and one subarray starts from here and ends here, which is fixed bound. Another subarray starts from here and ends here, which is also fixed bound. One from here to here, that is also fixed bound. So we want to count how many fixed bound subarrays end at current position I. And how can we do that? So let's say there was either min k or max k here, and another here. So we should have both in the subarray. Only having min k or max k will not work. So till we find both min k and max k, the subarray, fixed bound subarray ending at current index will be 0. And once we have both the values, idx1 and idx2 greater than invalid index, then we know that now we have a valid subarray. So at the first point where we have, let's say here idx2, this was idx2, that is this was maximum equal to max k. But we see that idx1 is still lying here somewhere before that invalid index. So we haven't found idx1 yet. So this is less than invalid index. So we will not add anything. But now let's say we found another idx2. Still only idx2 is there, idx1 is not there. Now let's say somewhere down the line we found idx1 also. Now we have a valid pair. So how many subarrays ending at this position is valid? So it will be from one index after invalid index to this array, because it includes both. So it includes both min and max. So it is a valid subarray. Next, this is the first point, let's say, and this is the second point. This is also first point. So from the next index till here, also it includes both idx1 and idx2. So this is also valid. This is also valid. This is also valid. This is also valid. Now if we advance further, this will be not be the part of this array. So what is the count? Whatever is the min of idx1 and idx2, min of idx1 or idx2, maybe max occurred before, so that's why we are taking whatever is the left bound of this smallest subarray that contains both min k and max k. So whatever is the min minus this part. So if there are 10 elements here from invalid index to this minimum of these two, then 10 subarrays are possible ending at this the larger one. So from here till idx2 to idx1. So whatever is the min minus invalid index. And we can keep a global counter. So we will add to the count. That's it. Now let's say we found, so this part is still valid, but we found, so let's say idx2 was here, idx1 was here. Now let's say we moved here and we found another idx1. So this does not change anything. Still the minimum is here and invalid index is somewhere here. So for all the values starting from this index, one more than invalid index, till this idx2 will be added to the count. Now let's say we found, now idx1 is here. So we can forget this because we have already accounted for all the subarrays ending to all the previous indices. Now let's say here we found idx2. Now what we should consider? Now we should reset this idx2 because if you see, if you don't update idx2, then only let's say there are 10 values here. So only starting from this index, these 10 values and ending at this will result in valid value. But you see that even if you go past this earlier idx2 from here to here, still valid because it includes idx1 and 2. From here to here, still it includes idx1 and 2. So that's why you, whenever you get a new min k or max k, you update that value. Now this idx1, which was larger, and this idx2 was smaller. Now this is the minimum. So all the values from this invalid index till here, anything starting from these and ending at current index, so we are currently here, we will add all those counts because all those are valid fixed bound subarrays. So this is the general approach. And we were looking inside one valid subarray between one break. So the array is broken into multiple parts with those out of bounds values. So, so let's analyze the time complexity. So clearly it's O of n. We are just scanning this array from left to right. We are not revisiting any node. And then space, we are keeping a couple of indices for min k and max k. What was the last min k and max k element? Min k and max k indices. And also what was the invalid index? So 3 values, so O of 1. So the code for this will be pretty simple. So let's write the code for this. So int n is the size of nums. Then we have idx1 equal to -1, idx2 equal to -1, and invalid idx equal to -1. And then we have to return a long count is 0 for I equal to 0 to n-1. So if the number is out of bounds, so if nums I is less than min k or nums I is more than max k, then it's out of bounds. So this is the invalid index. So if next element is also invalid, we will keep the rightmost invalid index because after that valid index starts, valid numbers starts. Then if nums I equal to min k, then idx 1 equal to I. If nums I equal to max k, then idx 2 is I. It may be possible that both min k and max k are same as in the second example here. So that's why we are not writing else, because the nums I can be equal to min k as well as max k. So if we write else here, we will skip that thing. Now we have all the indices. Now what we saw, count plus equal to whatever is the min of idx 1 and 2, that minus invalid index. And we are looking this only if idx 1 and idx 2 are more than invalid index. So if one of them is less than invalid index, then this value will be negative. So in that case, we actually need to take 0. So we can take maximum of, if idx 1 and idx 2 are more than invalid index, this value will be positive. If it's less, then we take 0. And that's it. We can return count. So the base case is passed. Let's submit. And the solution is accepted. So I hope you understood this problem. So see you in the next video.